Hello everyone, and welcome to the Cloud Lunch and Learn sessions. My name is Hugo Barona, and today myself and João will talk about Azure Reference Architectures, and specifically event-driven and event sourcing architectures. So before we start, I would like to appreciate our collaborators, and if you did not join Cloud Family, I would suggest you to do it so you can join an amazing team of cloud professionals and experts and access to a central repository with useful resource related to the clouds. Also, we have the meetup group .NET Mafia that hosts amazing virtual and in-person events related to Microsoft technologies and Azure. So if you did not join this group yet, please do it, so you can also connect with the IT professionals in the group. So I would like to start by providing you an introduction of myself. I'm an independent contractor and certified Azure Solutions Architect with experience in software development while using Microsoft stack technologies and leveraging the open source technologies. I'm also a Pluralsight author, delivering courses related to Microsoft technologies and Azure, a public speaker, and a contributor to the tech community.
Hi guys, my name is João Gonçalves. I'm currently working as a solutions architect for the IT consultancy version 1. I have been working with software development and architecture for more than 10 years now, more specifically Microsoft and Azure. And I'm also an Azure architect and Azure DevOps certified.
In terms of the agenda for today, I will start, this session is composed by two parts. The first part, I will start by talking about event-driven architecture. So we'll talk about topics such as a synchronous messaging model and the different messaging options we have in order to use this architecture. And also I'll present some architecture models being used nowadays. And we end up this first part with talking about the benefits and challenge of using this architecture and a final demo showing how to build an event-driven architecture.
Yeah, my bit is going to be about event sourcing. So I'll give it an introduction, what it is, some best practice and guidelines if you're trying to, or if you're planning on implementing it. Talk a bit of how it works and how it connects with some other patterns like CQRS, benefits and challenges, and I have a small demo at the end.
Okay, so now let's start by talking about event-driven architecture. Before we start to talk in detail about event-driven architecture, I want to share with you important concepts related to this architecture and patterns, since these concepts will support your decisions on how to design your applications using this reference architecture. Since event-driven architecture is based on communicating events between the service and components that compose your applications, one of the key decisions while designing your applications is to decide the messaging framework you will use. Typically, a messaging model is composed by three main components. You have the producer that produces the message and send them to the message broker. Then you have the message broker that is responsible to receive those messages and send them to the different consumers related to those messages. So then the consumer can consume the message and do whatever they need to do in relation to the message. In terms of messaging options, it's important to differentiate the message and events because they have different concepts and may influence the way you design your applications. So message typically express an intent and expectation from the producer. So the producer is expecting the consumers to do something once they receive the message. You can also consider the message as a form of commands sent to the consumers to perform a given task. On the other side, events are meant to express facts to the consumers. So the producer is not aware of the consumers consuming the events, and they don't have any expectations in terms of what the consumer will do with the events. Also, on Azure, depending if you are using message or events, you may be limited to the options of messaging service you can use. And as you can understand, that brings other technical difference on how you implement your producers and consumers and how they send or consume the message or events. I just include here a simple visual diagram that explains how maybe the messaging model when using message or events. As you can see on messaging, we have a node A sending a message to node B, and potentially the node B can respond to node A, whereas on the eventing, basically we have a node A producer sending events and basically are not aware of the consumers of the events, and then the consumers basically just receive those events and process. So a typical event-driven architecture is composed by 4 logical layers. So we start with event producers that represents the facts as message and send them to the event processing engine via the event channels available. The event processing engine may perform some assertions to the events, for example, to identify the list of customers to send the events, or even to understand if it should send the events at that moment or not, depending on the rules we configure. Then we have the event consumers that can create filters to receive a subset of the events or even receive them all. Now, in terms of talking about the different models that we can use in this architecture, we have the publisher and subscriber model that basically process discrete events and send those events to the subscribers using the subscriptions we configure. It is important to keep in mind that this model will send the event to the consumers as soon as it is available. A practical example using this model on Azure would be your application sending, for example, emails to a given manager when someone creates a resource in a given subscription or resource group. Then we have the event streaming model that is used when you need to stream a high volume of events and let the consumers consume the events on its own pace. So basically the consumers do not subscribe to the stream, they just manage the position in the stream and advance its position as much as they want. We have different ways of processing the events in our applications. So let's see some common ways to process them. We can just perform a simple processing of the events. So we receive the events and use its raw data to perform a set of tasks. An example using this style would be using Azure functions with event grid trigger. Then we have complex case while processing the events. So scenarios when we have consumers processing a series of events, trying to find patterns in the event data and performing actions according to the values obtained. An example of this scenario would be using stream analytics to perform calculation of average number of clients in store per hour and send emails in case number of clients go below a given threshold. Also, we have the event stream processing scenario. And in this case, we have channels to receive the events and feed them to stream processors. The stream processors will process them and optionally transform the stream. In this scenario, you can use multiple stream processors to transform the data in different ways to be used by different components of your application. An example of using this scenario is using IoT hubs to receive events and then use Azure function to receive the stream of events and process them. So depending on the scenario that you are implementing on your application, it may guide you on the messaging service that you need to use, basically. Now let's see some common scenarios of using the event-driven architecture. We start with scenarios when we have multiple systems that we need to process the same events. This architecture is a good fit given its scalability characteristics and the capacity to have multiple subscribers to the same events. Also, this architecture is a good fit for scenarios that we need to process events in near real time, and when we need to do some kind of aggregation of data over specific periods of time. And of course, scenarios that we need to process high volume of data at high velocity. So these are just a few scenarios of using this reference architecture. I would recommend you to have a look to the Azure Architecture Center. So where you can have access to an extended list of resources, including examples of using this reference architecture, so you can get more insights about the different Azure service you can use and the scenarios where this architecture is the most recommended. I just want to quickly highlight few Azure messaging service available so we can understand some important difference when using message or events on our applications. We start with the Azure Event Grid, and as you may know, this is a service that allows to process discrete events using a push model and enable your applications to achieve high availability and scalability. Then we have the Azure Event Hubs to process series of events and stream millions of events per second and build data pipelines to respond to those events. A real-world scenario of this service being used is, for example, to process telemetry received from different sources, including our applications. Then we have Azure Service Bus that represents an enterprise message-driven service that gives you features such as transactions, detecting duplicated message, or even ensuring the ordering of your message. Also, we have many other services such as IoT Hub that manage events received from IoT device. We have Notifications Hub that manage mobile notifications, and we have Storage Queue that allows to use basic message processing, but you do not have features such as duplication detection, transactions, or even the ordering of message. So as you can see, you have many options of messaging service available, and the option you should use depend on multiple factors, including your application requirements, from where you are receiving the data, and how you are processing the data, and many other factors. So let's summarize some of the major challenge and benefits of using this architecture. In terms of the challenge, one of the big challenge is related to handling failures and ensure resiliency on your applications, given the fact that it is composed by multiple distributed services, so it increases the complexity of our applications. Sometimes it may be challenging to ensure that your actions are idempotent, especially in scenarios that you need to repeat a given event. So you need to ensure that you will not obtain a different result than the expected. Also, ordering and application may be a challenge as well, depending on the messaging service that we are using. And of course, considering that we are reporting telemetry to monitor each of the services that compose our applications, sometimes to simplify the troubleshooting of a given problem, we may need to correlate the telemetry reported from the different service, and this can be a challenge depending on the way the applications are designed. So now it's time to talk about the benefits of using this architecture. So we start with the benefits of enabling us to build loosely coupled systems by using the event channels to integrate the different services and abstracting those services from each other. So in this case, we don't need to use direct point-to-point integrations between the services, and we can easily achieve high scalability. And in case it is a requirement, we can achieve near real-time data processing. And of course, to finalize, one of the best benefits, in my opinion, is the costs. So using this architecture, you can also leverage the Azure serverless and consumption pricing model, and you do not need to allocate compute resource to be waiting for something to happen on your systems. You just subscribe to events, and when those happen, you process them, and you end up paying for only the resource it was consumed while processing those events. So it may be a really cost-effective solution, basically. So in terms of anti-patterns, follows few of the anti-patterns while using this architecture. So scenarios that we start to create many events without considering if we really need those events. So increasing the number of events consequently increase the complexity of our system. Also, scenarios that we are using generic events makes our system hard to understand and to manage the logic on the service processing those events. Also, depending on the design of our applications, your service should not depend on the order of the events or even detecting duplicates. So I pulled this sample event-driven architecture from Microsoft documentation to give you a visual example of using an event-driven architecture. This is a scenario of a web app that exposes APIs to external users to perform actions related to trips. So we start with the API gateway. So in this case, using API management to expose the endpoints of the backend service so the client's application can consume them securely. Also, it helps by decoupling the client side from the backend, since you can easily manage change on where the service are actually hosted from the gateway without affecting the client application. Then we have the entry points, so the public-facing APIs that the client application will be using, powered in this case by Azure functions responding to HTTP requests. Then, in case we need to have workflows, we can use workflow orchestrations, such as in this case Azure Durable Functions, that represents the middle tier service to interconnect the public-facing APIs with the actual backend service that are tied to the data stores and other critical components. And we can orchestrate the work of this service based on actions on the client side. Then it is using event grid topics to handle service intercommunication and pass along information and data between the different services. By using an event-driven approach, we are also favoring service decoupling, since the information exchange will have a fire and forget approach, with the service pushing events and handlers subscribing to those events for processing. Then, of course, we have the backend service that are directly operating with the data layer and other components of the solution, isolated from the rest and easily replaceable if needed, So for example, we can easily change the type of database used to store the data without affecting the rest of the application and interactions. So just follow the link to give the attribute of this diagram. On this link, you can access the article available on Microsoft documentation that will basically give you more details in relation to this sample, and also you can access the source codes and more. So let me now show you a simple demo of an event-driven architecture. I decided to use this opportunity to demo an app built on Dapr. For the ones who don't know Dapr, Dapr stands for Distributed Application Runtime, and it's basically an open source initiative with the purpose of creating a portable event-driven runtime, platform agnostic, that enables us to build microservice applications using our favorite programming language, and that can run on any infrastructure on the cloud and edge by using standard open APIs. Follows the link of the official Dapr websites so you can read more information about it. Also the link for its GitHub repository so you can access the source codes, documentation, and some samples that allow you to start using Dapr. So let's start our demo. I'm going to just share the screen with you. So basically, this is the GitHub repository for Dapr. They have here an extensive set of samples available that allows you to quickly test your Dapr runtime and build your applications. In this case, I just pulled this sample. Basically, this sample is related to the publish subscriber model. So basically, we have here a React form that's basically publish events to Dapr runtime using Redis, Redis cache, and then basically Redis have, in this case, two subscribers, a Node.js app and a Python app subscribing to the topics and receiving the events. I did a small change on this sample in order to show you how easy it is to change these components that are being used on your application in the Dapr runtime. In this case, instead of using Redis, I'm using Service Bus topic to basically manage all the events. So I'm going to start by showing you the source codes. So on the source codes, basically we have here two subscribers, the Node subscriber and the Python subscriber. The Node subscriber has an app.js file that's basically use an Express API, and there's a method, a get methods that is Dapr subscribe, and this method basically returns an array with all the topics that this subscriber is subscribing, and also has two methods, post methods for each one of the topics. So what happens is when an event gets published to Service Bus, Dapr will basically call these methods to inform the subscriber that a given event was received. The same happens with the Python subscriber. Again, Python subscriber, we have here root to a get method, subscribe, returning the topics. In this case, the Python is subscribing to A and C topics, and then post methods for the A and C topics. Okay. So now I'm going to open the app. So I have here, I will run the app on my terminal. In this case, I will run the Node subscriber and the Python subscriber. And also I'm going to open a tool called Service Bus Explorer. For the ones who don't know, this is available on GitHub. You can download, and this basically provides you a user interface to perform simple tasks in relation to your Service Bus instance. So in this case, I have already my service bus here available. I have here my topics A, B, and C created. So if I just say to send a message, let me just resize here the window. If I say to send a message to topic A, I'll specify the format as JSON. And if I send the message, as you can see here, the Node subscriber received the message and the Python subscriber received the message because both of them are subscribing to this topic. But now on the topic C, sorry, if I send the message to the topic C, basically I'm expecting that only the Python subscriber will receive the message. So if I again select the message format to JSON, start, and as you can see, the Python subscriber received the message, so this case the event, but the Node subscriber did not receive the message because it's not subscribing to the topic C. And also the important detail here is this change to use service bus instead of using Redis was made by just performing a configuration change. So in this case, on the Node subscriber, I have here components, and on the pub/sub YAML file with the configuration, I just configure here the type of pub/sub that I want to use. So instead of using Redis, in this case, I'm using Azure Service Bus. This is basically an implementation of the building block available on the dapr runtime source code that allows you to easily change the configuration and use the implementation. And as you can see here, I changed the configuration and easily I could connect this service with Service Bus instead of Redis. So now let's get back to the presentation. So now it's time for questions. I don't know if do we have any questions in the channel so far? Sure.
No, I think the chat is clean. Yeah.
If you have any questions, João, do you have any questions that you'd like to ask?
No, I'm okay so far.
Yeah. Okay, so we should be good to continue, and then in case you have questions in relation to this part of my presentation, you can always ask it in the end. So João, can you share your screen, please?
Yeah, just give me 1 second. Okay. So, event sourcing. First, welcome to the second part of this Cloud Launch and Learn session. I'm going to talk a bit about event sourcing, nothing too advanced, more like the basic concepts, what it is, and what benefits and challenges it gives us when implementing it. So hopefully by the end of it, you'll have a better understanding of this pattern and when it might be suitable to use it. So like as Martin Fowler describes it, event sourcing ensures that all changes to application states are stored as a sequence of events. Not just can we query these events, we can also use the event log to reconstruct past states and as a foundation to automatically adjust the state to cope with retroactive changes. This means that event sourcing really is like a storage strategy where state is persisted as a sequence of events. Now, we came from Hugo's talk about event-driven architecture, and event sourcing is actually a pattern that actually has event in its name. What really is the connection between them? So event sourcing is something a lot more specific. It not only promotes the use of events, but it demands that events are the only way to change and store application state. So you can say that event sourcing is event-driven architecture taken to the storage level. So in an event sort solution, we instead look at the world or our business requirements as a sequence of events that happens. So if we're thinking, or when you're thinking about implementing something that make us think from the event sourcing perspective, it kind of helps to have some rules or guidelines to apply. So the first two tells us that the events are appended to an ever-increasing data store of events. And once an event is saved, we never modify it. If, for example, a mistake was made, we don't delete that event. We just append another event to correct that mistake. And since those events will contain facts about what actually happened at a point in time, they should be named in the past tense, just to emphasize that they represent something that happens and will never change. It also helps if we name the events using a language that's related to the business, so that events can be used to track the story of what really happened to the business back in time. Tracking the order of events is also essential. You might need to replay those events for some reason later, or even if you just need to present them in a user interface. So how exactly does event sourcing work? Let's take the example we see on the screen. We have a conference management system where users can make seat reservations. And before I talk about the flow, let me just talk about a couple of concepts. We have events, which is something that happened in the past, and events are not the current state of our entities, but it's what's going to lead to the current state of the entities. We have aggregates, which is a concept in our business that models a number of rules against an entity. So we can say our aggregate is a piece of logic that, for example, says yes or no to requests sent to our system about a specific entity. And if the request is successful, the aggregate updates the state of the system by appending an event. And we have projections. Projections are views of the current state and are generated by projectors, which are processes that go through all the events and transform these events in a view that can be consumed. So if we go back to our example, we'll start with our user. So he wants to reserve a seat for a conference, let's say Microsoft Build, for example. So it triggers the command. That command goes to the MS Build conference aggregate. And that aggregate contains all the information he needs about a conference. So it's going to validate if there are enough available seats by querying a projection. If there are enough seats, the aggregate then appends the event to the store with the number of seats that were reserved. Another pattern that is heavily used with event sourcing is command query responsibility segregation. So it's a pattern that states that every method of an object should be either a command or a query. And queries return data, but do not alter state. And commands change state, but do not return any data. This separation makes it easy to understand how states change in the system. It also describes the concept of having those two different models completely separate from each other. So having the right model separate from the real model enables the use of the most appropriate strategy and technology to each one and allows both to be scalable independently. So for example, we can have the read model optimized for queries and reports and built on top of a NoSQL data store specific for searches. So after we put event sourcing and CQRS together, how does it look like? And as you can see from the slides, there is now a separation between the event store and the read model, and changes to the event store are communicated through some sort of message bus. We have the UI triggering the requests, going all the way to the aggregate, which in turn will decide how to respond to that request. This request was actually successful, so now it can be appended to the event store. And afterwards, a message is sent to the bus that will trigger an event to run the projections and update our read model. In our conference example, we don't really have this separation of reads and writes, but it's always worth demonstrating how these two patterns work with each other and how it looks like visually. So what are the benefits that we can get from event sourcing? We'll have a complete log of every state change ever. We have unmatched traceability. Since our events are immutable and append only, we have an audit trail that we can use to monitor every event and action. And if we need it, we can regenerate the state of an entity at a particular point in time or from scratch by replaying all the events. It's also useful because we'll have a full understanding of what the system is doing. So it helps a lot if you have to investigate and debug some sort of issue in the system. Another benefit here is that having this log of events, they can then be used to analyze, let's say, user behavior and get some trends and any other type of information that might be useful for the business. We have improved performance and scalability. Since the events are typically processed on the backgrounds, the user can continue their work and there will be no wait period from when, for example, we're dealing with transactions. And flexibility, also because our sequence of events can now be projected to any desired structural representation. We can also consider event sourcing to be extensible. And thinking back to Hugo's presentation with event-driven architectures and how they can be used, we can have multiple tasks handling a specific event and have integrations with other systems and services. Challenges of event sourcing. An event sourcing system is naturally eventually consistent. This means that whenever an event occurs, other systems won't hear about it immediately. There is a short delay before they receive and process the event, gaining consistency. This means that you can't guarantee that a date in your projection is immediately up to date. In some cases, we need some way to handle simultaneous requests from different users. Imagine two simultaneous requests to book a single remaining conference ticket. This situation requires some kind of structure around the aggregates to make sure that we're not creating inconsistency in our data. One option is to use some kind of concurrency check, optimistic or pessimistic, in the storage system. And events will change shape over time. And this can be a bit tricky to handle if you don't plan for it in advance. When an event changes shape, you have to write an upgrader that takes the old events and converts it into the new one. This can be done on the fly when you read the events from the store or by using some sort of migration strategy. One particular situation that was raised during the global virtual bootcamp a couple of weeks ago in a session about event sourcing by Duncan Jones was in relation to GDPR. The link to the session is in resource slides, so if you guys can, go please and watch it. It's really good. And in this situation, we have a request to delete all the user information in our system. And we can do that by either replaying all the events and removing that information by using one of these upgraders, or encrypting that information and just throwing away the key. The last one is the need of different mindset. It is quite the change of perspective when using, or when we have to start using event sourcing. And most developers are used to thinking in tables rather than events. So coming from that type of background usually makes the learning curve a bit more steep, and it can be a bit challenging. So when is a good fit to use event sourcing? If your domain is inherently event-driven, something like a sports game tracking, for example, let's take a football game. We need to track game starts, game ends, shots, passes, assists, goals, substitutions, and so on. Accountability and tracing is essential. So the first business reason for implementing event sourcing is quite simple, is that historical data is valuable. Take the medical domain, for example. Doctors keep track of your medical history by adding stuff to the end of your journal. And is that stream of events that helps with diagnostics. And if you want to get insights and drive business value from event data. Again, if you think about an e-commerce platform, for example, we can use technologies like machine learning and artificial intelligence to look at user actions and show the user some recommendations. So moving on to the demo. Before I move to the demo, just want to show exactly how it looks like in terms of architecture. So it's actually quite simple. I'm using a template from Visual Studio, React on the front end, .NET Core on the back end. I'm using the Azure Storage Emulator for storage, and I have a function listening to the queue when I build the projections. Now, when we're thinking about deploying an event sourcing solution to production, the key considerations is that like what we're going to use for our event store, since it will be the backbone of all this. So we'll have to consider things like availability, latency, and throughput. And like one example or one type of service that we actually can use for this could be Azure Cosmos DB. So, give me a second while I move to the other bits.
All good?
Yep.
Yeah.
Okay. And I'm not going to go into the codes and show you a lot about it because it's not a pretty site. But like it's quite the rudimentary application. It's very simple. It's going to show more or less what we had on the slide about the conference. So websites where I can actually create a conference with a set number of seats. I can reserve seats for that conference, and I can cancel them, and I can list all the conferences and see the available seats that they have. So we have just 2 pages, one where I can create events and another one that just reads projections. So let's say, for example, that I want to create a conference for the global virtual bootcamp, and we're gonna have 100 seats. We can click submit. So now if we go to our event store, we can see that the event was created. I have my unique conference ID. I have the sequence for the events, the event type, and the actual payloads, which contains the name of it, the seats, and the ID. At this point in time, a message was sent to the queue, and the function picked it up. So yeah, that happened, and create a projection for it. So if I go to the projections, I can get my list of conferences, and I should see the Global Virtual Bootcamp Conference and the available seats. So let me select it. Let's say I want 50 seats for my company. I click reserve. So what happened here was the conference aggregate looked at a projection to see how many seats were available, and then decides if there are enough or not. And in this case, since that was possible, it went through the process. So we should see now our seats removed event here for that particular conference ID. And if you go to our projection, it should be up to date now. So again, let's go select this again, and half the guys canceled. So we'll just cancel the seats. And we move back to the projection, and it should be 75 now. So we get the seats added event here. And if you go to the projections table, we can see that for Global Virtual Bootcamp, it actually says 75 seats. This is the last event that was processed, and everything is up to date. I do have a particular projection here for a lookup, and I have it this way just to highlight a particular fact that projections should be autonomous and independent, because you might get into a situation in the future where, like, if you have projections that depend on projections and something happens to a particular projection, you can have, let's say, gets deleted, it's not necessary anymore. That can have cascading effects on other projections and break your system. So yeah, this is for the demo. This, as you can see, quite simple example. So Hugo, I think now it's like we move to questions.
Yeah.
What's next?
Do you want me to share the screen or do you share?
Just have to, let me just stop it here.
Okay, give me just a sec then. Let me know if you can see the screen.
Yeah.
Okay, perfect. So let's see if we have any questions on the channel. I was checking a few minutes ago and no questions. Yeah, no questions so far. I actually have a question for you, João. So in case the people attending this session, in case they want to learn more about event sourcing, what would be the best place that you would recommend to start off to learn more about this architecture?
I would start with the Azure Architecture Center. It actually has a very good article about event sourcing. I would also recommend to watch the session that I mentioned in the slide before from the Global Virtual Bootcamp, where it actually goes through a bank account example using Azure Functions. And then I would just say don't start looking at too many things, because event sourcing, you can get into a bit of a rabbit hole, and then you end up spending days and days reading about it. But yeah, those two I think would be a very good starting point.
Yeah, definitely. Sorry, I just noticed that the screen share was gone. Yeah, back again. So before we move on, I just want to ask everyone, I'm gonna copy a link to the channel. So please, the link is for a survey. So we are basically trying to collect data and feedback from you in order to understand if the sessions are meeting the expectations, or if you have any suggestions how to improve these sessions. So you are more than welcome to provide some feedback. And also I have another important factor. So here we have a list of all the resource compiled related to this session, and also follows the list of our contacts in case you want to reach us with questions, with comments, or even to just have a simple chat. And also I want to ask you, this session is supported by Microsoft as well. So in case you want to access free resource related to this topic, please just scan the QR code or even access to this AKA MS link, and you should be able to just submit the form and access free useful resource related to this topic. And of course, if you have any questions, even after we finish this session, you feel free to contact us and share your questions, and we can try to help you. And I think that's it. Thank you so much for joining us, and I hope you you enjoyed the session and understood what we presented here related with event-driven and event sourcing architectures. And wish you a nice day, and thank you so much.
All right, thank you guys. I really hope this was useful.
Yeah, I'm gonna just stop, and please, people, just provide us feedback. It's definitely really useful to understand how we can improve. Our main goal is definitely improve those sessions, especially understanding which kind of topics interest you, so we can start to drive and deliver more sessions related to the topics that you are interested on. And from my side, I can definitely tell you, if you have some time, definitely have a look to the DAP runtime, because it's definitely an amazing initiative created by Microsoft, and that you can start to build your event-driven applications by using this runtime. And you can basically build portable applications using your favorite programming language, and you can run it locally on your local machine, on the cloud, any cloud provider you want, preferably Azure, of course, and on the edge as well, if you have any edge device that you want to run your applications. And that's it. Have a nice day, and thank you so much.